Okay, today I want to talk a little bit about unit conversion and temperature scales. In some of my other recent videos, I've been talking about dimensional analysis, which is also called the factor label method, which is one way we can convert from one unit type to another using the ratio between those units to get from one scale to another. So I want to talk about how this plays out with temperature because it's a little bit different and it kind of depends on the scale that you're using and what you're trying to get those units into. So to introduce, temperature itself is the measure of how hot or cold something is compared to some sort of standard. And everyone kind of knows that. We know what temperature is. We know what thermometers are. That's our way that we measure temperature. But as chemists, we think about things at a particle level. So when we're talking about how hot something is, then the heat of it comes from kind of the average of all of the little particles of that substance that are moving around. So it's the kinetic energy of moving particles that we perceive as heat. And we'll get into this in later videos when we talk more about energy and heat and all that calorimetry, all that good stuff. But for now, we're talking temperature. And there's really three important scales that we look at. We in the United States with the US customary system use Fahrenheit. The rest of the world uses Celsius, and then we as scientists use Kelvin. Kelvin is our SI unit for temperature, and it's the standard that we use when we're talking about standard temperatures and pressures. Then that's usually going to be reported in Kelvin. Now you'll note that Celsius is in degrees of Celsius, so it's degrees of that temperature scale, as is Fahrenheit, degrees of Fahrenheit, and Kelvin is just Kelvin. It's like a meter, right? It's just the unit in and of itself. It's not a degree of Kelvin, although you sometimes hear people say that, and I slip up and say that every once in a while too. So we give each other grace if we say degrees of Kelvin, but you don't need it. So in order to kind of look at these different scales, I think it's important to compare them using water as kind of a metric, because we have experienced water and we interact with water, so we kind of know what it looks like when water boils and freezes. With Celsius, the scale is built around water, and water freezes at 0 and boils at 100. So the person who created the Celsius scale just said, well, this is water. Water is important for living things. We'll call the point at which it freezes 0 and the point at which it boils 100, and then we will shake everything out from there. So Celsius is really useful when we are measuring the temperature of solutions, doing a lot of lab work, because they have nice round numbers when it comes to interacting with water or aqueous solutions. Now Fahrenheit, which is more familiar to Americans, water freezes at 32 degrees Fahrenheit, and it boils at 212 degrees Fahrenheit, which those numbers aren't as pretty and round, but they are named after the scientist that created this scale. And again, it's measuring it according to some sort of standard. This is the standard that the scientist came up with, and here's our freezing and our boiling points. With Kelvin, water freezes at 273.15, and it boils at 373.15. So if we're comparing these scales and looking at which is bigger and which is smaller, and kind of how these units relate to each other, how they compare to each other, then I think it's important to look at the difference between these 2 points, because these 2 points physically have meaning, and so if we compare them with each of the scales, then we get a sense of magnitude for each of the units. So with Celsius, there are 100 units between the freezing point and the boiling point. Whereas with Fahrenheit, there are 180 units between the two. So as scientists, we're comparing things, we're classifying things. If we're looking at these two scales, we would say, well, a degree of Fahrenheit then is smaller than a degree of Celsius, right? I can fit more of them in the same amount of space, so the magnitude of 1 degree of each of these is going to be different. I'm going to have a larger amount of a Celsius degree than I have of a degree of Fahrenheit. Now, if I compare that to Kelvin, again, there's 100 units between freezing and boiling. And so in terms of Celsius, then, Celsius and Kelvin are the same magnitude. A degree of Celsius and a Kelvin are the same. but they start at different points in the scale. And the reason that Kelvin starts where it does is because Kelvin can never be a negative number. We can have negative degrees of Celsius, we can have negative degrees of Fahrenheit, but we can never have negative Kelvin, because 0 Kelvin is absolute zero, and that's the point at which all of this motion, all of the energy of these moving particles is no more. No motion means no heat, so that's 0 Kelvin, absolute zero. All right, so if we're converting between these, so if we're trying to figure out how to convert from one scale to another, Celsius to Kelvin is really the easiest, right? If I go from Celsius to Kelvin conversions, all I have to do is add 273.15. That's our magic number for Kelvin, and that's going to be an important one to know. Years and years later, you'll remember this, going from Celsius to Kelvin, because you'll use it all the time. And then kind of the opposite is true. If I'm going from Kelvin to Celsius, then I'm just going to subtract my 273.15, right? Just the opposite of my, I'm going to undo that, right? So Celsius to Kelvin is kind of a good way to go. That's why we like, as scientists, to measure, have our measuring tools in Celsius, because it's a nice, easy conversion to our SI unit. Now, when it comes to Fahrenheit and Celsius, we have to account for this difference in the starting point. So whatever we're talking about in terms of Fahrenheit, we have to account for with our 32-degree difference between the starting point, and then I have to account for the difference in the magnitude of the units. So there's 1.8 degrees of Fahrenheit for every 1 degree Celsius, and then we have to add or subtract the 32 depending on whether or not we're going from Fahrenheit to Celsius or Celsius to Fahrenheit. So let's do some practice with these in order to kind of make sure that we know what's what. All right, so if we're going to convert 25 degrees Celsius to Kelvin, we said this is the easiest one. We're going to be adding then our 273.15, that's our magic number. And when we add this, then we get 298.15 Kelvin. Now, if we're thinking about significant figures, because we are always thinking about significant figures, because that represents the precision of our measurements, then when I'm adding, the rule is that I have to round my answer to the number of decimal points that's the lowest from the numbers that I'm adding together. So I have a ones place here, I have a hundredths place here. That means my answer has to be rounded to the ones place. So I'm looking to this 0.1 to round, and I'm going to round down. That gives me 298 Kelvin is my 25 degrees Celsius. And this is going to be an important value moving forward. When you talk about standard thermodynamic conditions, it's usually at 25 degrees Celsius or 298 Kelvin. So this is going to be something that's pretty familiar as we move forward in our chemistry careers. Now let's talk about converting Fahrenheit to Celsius. Now this is where we have to take into account our difference in the starting point. So we have our 134 degrees Fahrenheit, but the first thing I have to do is account for that 32 degree difference. So I'm going to subtract those 32 degrees, and that's going to give me 102 degrees Fahrenheit. Okay, so we're going to add or subtract based on where we're starting. If we start with Fahrenheit, we have to get rid of that before we convert it to Celsius, because when we use dimensional analysis to convert from degrees of Fahrenheit to degrees of Celsius, I can't account for that 32 in this ratio, right? The 32 is separate from the ratio between the two. We said there's 1.8 degrees Fahrenheit for every 1 degree Celsius. And when we plug and chug there, that gives us 56.7 degrees Celsius. Okay. All right, if we're thinking sig figs along the way, then when we subtract here, we have to have a ones place, right? Addition and subtraction means that we're going to have a ones place. I have 3 significant figures here. That 0 in the middle is significant. Now this is a ratio. This is an exact number. This gives me a definition of 1 degree Celsius for every 1 0.8 degrees Fahrenheit. And so I'm going to have 3 sig figs, which limit my answer here to 3. So that's 56.7. All right, now let's go the other direction. Let's go from Celsius to Fahrenheit. So this one we're going to have to add that 32 at the end. If we have 32 degrees Celsius, we're going to go from degrees of Celsius to degrees of Fahrenheit. So we're going to kind of do the opposite here. For every 1, we have 1.8 degrees. And that's going to give me 57.6 degrees Fahrenheit. Now you'll note that I'm leaving my significant figures here. I only have 2 here, so I'm going to have 2 in my final answer, but I need to add my 32 here to account for the difference in the starting point. And so when I add that 32, I end up with 89.6 degrees Fahrenheit. And now to round that to 2 significant figures, that's 1, 2 that are significant. I look to this 0.6 to round up or down. It's greater than 5, so I'm going to round up. So when I round up, it's 90 degrees Fahrenheit. The problem with this is that that 0 is ambiguous, so I can either put it as a decimal point here, so 90 with that point means that that 90 is significant, or I could write it in scientific notation, which is kind of a weird way to write temperature. So I think that this would probably be the better way to go when we're converting to our degrees of Fahrenheit here. Okay, so that's just kind of a quick rundown of how we use dimensional analysis and also our knowledge of the temperature scales in order to convert between them. And as always, if you have any questions, please don't hesitate to reach out.